I guess we will start then. Hello, welcome everybody. My name is Matt McLaughlin. I work for EventStore as a developer advocate. The idea behind these sessions that we're running occasionally, we've run one with Alexi, one with James now, and now we're running one with Chris. I'll allow him to introduce himself in a second. But the idea is that we just wanted opportunity for people to ask questions about EventStore, ask questions about event sourcing or any of the related patterns and ideas. We will do our best to answer them, and yeah, that's about it. So today we've got Chris Condron, who works at EventStore as well. Do you want to give yourself a quick introduction, Chris?
Sure. I've been working, actually I've been with EventStore for nearly 10 years, depending on how we want to count the numbers, because the company I was working at was the first commercial customer for EventStore, as it turns out. And so my first application was the first supported app way back in yesteryear. I'm now working at EventStore, full time. Started off with event-driven systems in telecom with voice over IP and packet switches back in the late 90s. And ran into Greg Young, I don't know, about 10 years ago. And he turned me on to the pattern and the tooling, and I haven't been able to stop using it since.
Cool. So we don't have tons of people here, so we've got a series of questions that have all come in via the registration form. So we will start by, I'll start by asking Chris those, but if there's anything that comes up in the meantime or anybody wants to just interject, by all means post a question, and we'll do our best to answer it. So there's no real theme to these questions. They're just random curiosities that people had. So, but generally around event sourcing. I have a big list here, so we'll just pick one and we'll get started with it. And the first one is quite simple. How do you handle large volumes of commands?
So large volumes of commands?
Yeah.
Well, the general, so if you're talking about commands, I'm going to assume that you're dealing with some sort of user interactive application. And the way I deal with commands is generally I'll do, if I'm dealing with the UI, we'll just assume I'm talking about a UI here. I'll generally have a set of commands in the UI, which are gestures. And I'll have a context service that handles the UI commands and then correlates them with domain objects. If I click in a row, how do I know what thing I'm dealing with in backend? Generally, that'll be associated with an aggregate or some sort of ID. So I use a context service to keep track of the UI state and be able to translate simple gestures into more meaningful questions for the backend. Then I'll forward those commands onto the backend. I actually wrote an open source project, Reactive Domain, and that's the pattern I use. So I do what's referred to as sync over async. So I'll block the UI, interaction. I'll send a command off to the domain, and I'll wait for the domain to send back an acknowledgement that the command was either timed out, succeeded, or failed.
Yeah.
And then my domain services will handle that. They'll produce the events. And so I'll know by the time the command is ended whether or not it's passed or failed.
Yeah.
And I can wait for the read models. All my read models are always dynamically updated with push models, right? So generally when I come back, that read model is going to be there, or I'll know I've got the ID I can use to sync up with the read model. It's why I also like to use tools that give you a unique identifier generation in the UI. So that way when I append an ID to a command to send it in for processing, I can use that as the ID of the item coming back.
Yeah.
So I can always sync it up.
As opposed to generating it on the server side when you have no
exactly, because then I don't know exactly when is my thing going to come back. But this allows me to give the user a nice synchronous feel. And generally, it's very fast. I mean, you talk about sending everything around, but it's almost always, faster than the user is going to notice.
Sure. So, I mean, that's generally the pattern I use as well. But I mean, why? This is obviously a leading question, but why do you wait for the response of a command? You often see architectures out there that will put a bus or a message queue in between the command and the actual domain layer.
Yep.
so to speak.
I mean, well, that's why I'm doing sync.
Why would you not do that? Or
that's why I do sync over async. What I do is I extract the bus into like an iBus interface, so I don't know or care if I'm talking from my app to a local store. Because sometimes I'll run an app where every time you start the app, it starts up a store. Other times it's going over the internet, it's going over any other transport rabbit, but with a couple of adapters, because both commands and events are very similar to message TTOs, right? And so everything works the same way. And for large volumes, this allows you to scale up horizontally. If I need more things in the background processing, I can. And this is where it becomes really important. If you're saying the stream is generally the stream is your isolation point. That's going to be your transactional commit. You are going to be blocked in any architecture you do. You get table locks, you get, if you are trying to update the same item from multiple different places.
Yeah.
So you have to make sure that you've designed your system such that you've got independent objects that you're updating, and then you can update them in parallel. And the event sourcing approach even allows you, if you really need to do that, to have multiple stores that are all then coming back into maybe a roll-up or a common system in the back end. Yeah. So I can scale out on both the write side and the read side tremendously by making sure my isolation patterns are correct. And that's why fine-grained streams are critical. In those systems where, a stream or isolation point is similar to a table in a relational server, really, cause problems, because effectively you're table locking every time you want to update. Whereas with fine-grained streams, you're row locking. And if I can row lock and update independently, then I'm in a much better situation for large volumes of commands.
Yeah, it makes sense. I mean, that's a big argument for keeping your consistency boundaries as small as possible. Therefore, there's less chance of things, multiple things trying to update the same thing.
A stream per instance is the pattern. I've heard it called.
Yeah. Cool. Let's try a different question then. Let me just read it first. Okay. In an eventually consistent system, so anybody who's built an event source application knows that often the read side is eventually consistent. A term I'm not a massive fan of, to be honest. What are some of the ways the UI gets updated when the projections are ready, especially in cases where the user is waiting for a result after issuing a request command?
Yeah. So the first thing is, I don't like the term eventual consistency for proper event source systems, because it's really more about staged consistency. Because formally, eventual consistency means everything can get out of sync and will eventually synchronize on a particular state. So if you think about, you're getting updates in a random fashion about a bank balance, you could have balances that never existed. Whereas with ordered streams, you might be a little bit stale, but you're not going to be wrong, right? I'm not going to get things out of order. We're not going to do that. So that's the first thing, is to understand that your UI is going to be stale. It's not going to be wrong. There's a reactive manifesto that came out several years back, and it talks about how applications should be reactive, and they should stop what I call the bucket pattern, or the well pattern, where I drop my data down a well, call it a database, and when I want it, I go grab a bucket and I pull it up. And the problem with this kind of model is I never know if it's going to be there. So do I just need to keep asking, hey, are you done? Are you done? Are you done? Much better is the flow or the stream model, where I want to send my data in, and then I want it to be pushed to me, right? This is what reactive, all these reactive architectures are about. So what I prefer to do is use the subscriptions to be pushing data. So as soon as any writes occur on the store, it's pushing those out to the subscriptions by topic and by other definitions, very similar to the way AMQP or any other topic-based system works. So I want that reactive update when I'm done. And then you layer in what we talked about before about sync over async, and now automatically I know that my remodel should be updated. And we were talking before, if my commands send back a success message and I don't have an update, I know at that point it is safe to do the query if I have to. So that's the other power of sync over async. I never want to do an actual sync, but sync over async is really good in those situations.
Yeah. Do you have a better term for eventual consistency, Ben?
Stage consistency or ordered consistency.
Yeah. I mean, the thing that always I kind of remind people of as well is the only person it's not visibly consistent to is generally the person who's executed the command as well.
Yeah.
Like nobody else who's using the system will be aware that there was any latency on it, because the latency is generally less than a second.
Oh, I mean, no, if I'm getting latencies over a couple hundred milliseconds, I'm surprised and I want to go tune things.
Mm-hmm.
So, and generally when I get in arguments with people like, well, it's going to be inconsistent. And I'm like, okay, well, how consistent do you want? Do you want 2 milliseconds? And you put a price on how much that's going to cost. And all of a sudden they're like, oh no, half a second is fine. It's like, generally I want it below a quarter second because the user isn't going to see that at all.
Absolutely. I mean, the latency exists in other places anyway.
Yeah.
It's not just in the updating of the projections, it's in the network latency.
Mm-hmm.
So to assume that anything is fully consistent globally is
right.
a bit of
well, if you really, really want to solve the problem, all you need to do is make the application that's local to the user the owner of the question at hand.
Mm-hmm.
So if it can make a decision and emit an event locally without checking anyone else, so you have true isolation and local control like a microservice. If you make each UI a microservice, it can answer the question synchronously and just post a command saying, hey, I did this, and you've got to accept it.
Yep. Yeah, 100%. Okay, let's try another one. Okay, hi Chris. I'm just learning about EventStoreDB, but asking questions anyway. There's 2 questions. The first one is how to discover events, any schema registration kind, or registry kind. So I assume we're talking about having, an event schema.
Yep. So generally what I do is when I'm in development, and most of the times when I'm building applications, I'll turn on the standard projections, and they're going to create streams for every event type. And, so the ET event type stream will give you every event type of that type in the system. The $CE with a category, if you name your streams with category-ID, that implies the stream per instance pattern. And that will let you group things by especially as I'm testing or developing, to see if my events are there. So there's a web UI, localhost 2113. You pull it up, it's going to give you all your recent events, all your recent streams. These category updates are going to be right there. The next step of that isn't so fun today, but has a really good answer for tomorrow. Today, you just run through the all stream and you can build up any information you need about it, and you can keep that current the same way you would with any other projection. But I'm actively right now working on future features around a full schema browser in EventStore that gives you all of your streams, your events, the sizing, all that schema enforcement. And we want to be able to actually allow you to specify schema and schema types on events, limit those to what categories will accept those schemas, because if you're using the instance inside of a category, and have something very similar to the SQL relational, the entity relational diagrams available for EventStore, and allow that formal sort of modeling. That's one of the big things that I'm looking to bring forward with the next versions of EventStore.
Cool. I'll make it a lot easier to query in the future.
Yeah.
Absolutely. And the next question this gentleman has asked is modeling events into a graph and modifying graph based on events. Mm-hmm. Now, this probably leads on to the fact that we're not a graph database. But yeah, do you want to talk a little bit about how you would handle that, basically? Yeah. So
I find that EventStore, when I'm dealing with graph queries and I'm doing things like I want to understand, say, like a marketing question, or query something out of LinkedIn, or understand what's going on, or like a user. I find that graphs are also really efficient for understanding relationships between groups of people and other things. and provide a really awesome set of queries and really powerful setups. And those are very easy to build from streams of events, right? A user was added, a user connected to someone else. So I can take a stream of events, filter out the ones that would build links or nodes, and apply those to the graph correctly and build that graph out. So what I would do is I would take event store and some sort of graph. Now I might use a graph database if this is something that's going to be long lived. I might use an ephemeral graph, right, and actually just build up the graph dynamically, because the event store is really optimized for those historical queries, right? If you want to query the history of an instance, event store can return that very, very quickly. And that's what you would need to build a graph. You say, take these 5 people, read their history back 1 year, build a graph, and depending on how many events it is, you can build a graph to answer questions about their relatedness very, very quickly. So does that answer the question?
Yeah, it does. I mean, this is one of the benefits of having this basically this history of every single event that's happened to your system over time, is that it's effectively a global transaction log. And if you've got another persistence mechanism more suitable to your requirements, such as a graph database or a document database, then it's quite easy to project that information into a format that's more suitable.
Well, and one of the other great things about it is there's things that you can understand. Just think about a social graph, right? If I just have a relational model of who's related to whom, right? I'm gonna miss things like, well, these 2 people are heavily have a large number of friends in common, but the request to have them become friends with each other has been rejected 5 times. Maybe they're in the same social circle, but they really don't like each other, right? Sure. You can't tell that if you only have current state in a flat structure. But if you have the histories of like they were friends and now they're not friends and all these things, I can know a lot more because I have that rich history information and figure out how to set that up in my graph than I might otherwise.
Yeah, I mean, it's great. You take it into the Facebook analogy, you'd be able to see basically somebody's friend circle develop over time and how it's increased or decreased, who's joined it, who's left it.
Yep.
I could actually see that as being something quite cool to replay lifetime, seeing how it works. And if you only have the current state of that graph, then it's almost impossible to do. If you have the entire history, then it's easy.
Yeah. And I've built systems with ephemeral graphs where, you build a graph on demand to answer a question and you just have, n of them in memory for the problem set and you just throw them away and rebuild them.
Right. Yeah. I mean, you talk a little bit about these in-memory, let's call them in-memory projections. I mean, you don't hear much of it in event sourcing circles of people having these in-memory projections. They would normally project straight to some sort of solid persistence like SQL or MongoDB or whatever. What's your argument for them? Why do you think they're good?
What I did was I said, okay, I started off, I was building an app and I wanted to do, my first app was actually based on Outlook and didn't have any other database other than EventStore, right? And so all the screens were dynamic. I didn't have someplace else to put the data, and so that worked. And that was actually really small. I was actually event sourcing the configuration and setup. We can talk about that a little bit later. What I found was I just put, I'll need to get to some sort of persistent store eventually. I put it on the backlog. And I ran it up and I did my tests and I'm like, this just works, right? Why am I having this? And so over time, I just started with my backlog and I said, okay, I know I'm going to have to put a database in. I know I'm going to have to do cache. I know I'm going to have to do checkpoints. Like I redid a whole product line and we had checkpoints and we're going to have to do snapshots and checkpoints. We know. That was on the backlog for 4 or 5 years, after we were in production, before we're like, oh, wait, hey, the data is big enough that we might want to do that. This one aggregate's getting a little slow.
Yeah.
And then all we did was we made it a hot aggregate, which is what, I refer to as when you just keep it in memory deliberately between calls. So we're literally doing a per call generation and we were fine. And then we just said, okay, well, keep a local cache of those in a dictionary. And if you have a miss, go and get it. And then that fixed the problem for another 2 years.
So rather than going straight to a database, your kind of idea is as a first stage, just rebuild the
Rebuild
aggregate
on
when you query
demand.
it.
Yeah, rebuild on demand. Do a read through cache,
Yeah.
then do Redis, and then do some sort of persistent cache, and then put it in the database. So it's like, what do you need? I'm gonna just add those as I need them, because why am I gonna add the complexity before I need it? Why am I gonna go and put this all in until I've proven my load won't handle it?
Sure.
Because if you're doing a targeted on-demand read of a stream or a set of streams, you can rebuild that very quickly. And if you're doing a live push notification, reactive, you can keep all sorts of things fresh all the time.
Yeah. So I mean, this was a question. So I can see how that would be, quick enough for querying an individual aggregate or maybe a couple. But when you've got large aggregation queries where you're wanting to, I don't know, find the ages of all the people who've gone through your system grouped by an age range or something.
Well, I mean, that's something where, if I know that query or I need that to be built, reporting databases and query databases are something you've got. Like I was rebuilding a legacy app that had a full reporting system to let users build dynamic queries. And all we did was we created a connector to the all stream, and we just kept that relational database populated, and that whole feature still worked. Sure. So, if you need it, use it, but just don't think you've got to start with it.
Cool. All right. Let's try another question. Okay. Always a fun one, and I'm pretty certain this comes up all the time, but what are Sagars and why do you need them? I will give you this opportunity to clarify your opinion on what a Sagar is and what it isn't, and when you need them and when you don't, because I think everybody's got a different opinion on this.
So, to my mind, the fundamental question we're talking about is if we say that we're going to do aggregate per instance, and we're going to say that the commit cycle on any particular aggregate or microservice, right, because it isn't tied in, is one stream. And now I've got this entirely independent stream of commits. And I need to coordinate it with another stream of commits. That's the patterns that we're talking about, is I need to take actions and organize things that are crossing effectively what the natural commit boundaries are in the system, right? And if you can take your problem and you can put it all into one stream, then you just have an aggregate or you have a microservice, a little state machine. And that should be your first stop. Your first stop is saying, if I can't do this on one owner, then I'm likely not modeling my system correctly. That's my first question. But then the next question is, well, okay, there's clearly cases where I want to do a transfer or I want to move things atomically from one thing to another. If those two streams share a common all stream, so they have a shared order between them that's guaranteed, then I can use the write-ahead pattern. And the write-ahead pattern says, let's take the bank account transfer. What I do is I write the intent to the stream before I take the action. So I would start off by writing a reservation message to the first account that I'm transferring from. So if I'm going to transfer $100, I reserve $100 for transaction XYZ. And I commit that event to the first stream. Now I commit to the second stream, funds received from blah, blah, blah with a transaction number. And then the third event is back in the first aggregate. I write, transaction complete, right? And that closes out the reservation. The reason to do this is at any point I can turn the power off and rerun a recovery job. And I always know where I am and how to finish it. And I can also start a timeout service or a later service, watching it after it starts in each step to say, if it's not done by this time, there's a problem with it, escalate it and fix it. And that's safe and guaranteed because there's a shared order. And each thing here is independent, atomic, works by itself. That can also be modeled as a to-do list as well. When we get to the position where I have two items that are not in the same system, There's no shared ordering between them. I don't know when things are happening. Now what I do is I create a stream to track the interaction between those parties. And it can be more than one, right? And so now I create an owner or a process manager to manage that interaction and deal with the various states that I've got that go on with that, right? And that you can call that a saga, you can call that a process manager. I call it a process manager, but that's the rule of thumb is like, if I've got shared state, I'm just use the state to do the orchestration. If I don't, I create a stream and it owns the orchestration. And so it becomes, for each of the instances of the orchestration, I have an independent stream that tracks the behaviors between that. And that can give you really powerful insight into your business logic. A lot of the most important things in your business happen around these multi-stage processes, right? And that's a process manager or saga. There's another name, I think, for saga, which is about a set of transactions you can undo, distributed transactions with undo capabilities. That is the entirely wrong way to think about anything in event sourcing. Event sourcing respects the arrow of time. We are always moving forward, right? So you should never think in your mind, oh, if this doesn't work, I'm going to undo it. You should think, if this doesn't work, how am I going to respond and do the next thing about it? The classic example Greg came up with was, you're selling snowplows and you've driven your snowplow from Ontario down to Kansas City, and halfway there, the order's canceled for whatever reason, right? You're not going to just undo shipping the snowplow because the guy drove it into the United States, right? You're probably going to say, okay, we're going to call, raise an alert with the sales guy. And he might say, okay, get a hotel room. I'm going to find somebody else to sell that to, right? But we're not just going to blindly undo it because things have happened. Things are not as they were. That's this whole concept of transactional magic that relational databases give you, where the universe stops and you can just, under the covers, move everything around and then restart the universe, is brilliant if you're on one box. But as soon as you're not in one box, you can't just stop the world. It's a horrible model for so many things. And the timeline flow model works so much better for real world and for distributed applications.
Sure. Yeah, I mean, I feel this is where applications go wrong in a lot of ways, is when they don't model the real world, real world situation. It's often the downfall of things. And you come across these problems in the way of constraints where people try and block you from doing things like, for example, using the snowplow. Mm-hmm. It might be, build a system. It's very rare that a system would be built to kind of accommodate the possibility of selling it on to somebody else further down the, right, in the local area where it currently is and things like that. The default answer would be, oh, let's just send it back, or at least that's what the system would model.
Right, in
the real world.
And you could also, it's not the best plan to always try and model everything. So it could just be like, if this happens, tell the snowplow to stop and alert the sales rep. Raise an alert to a human who's going to decide what to do. The process can take overrides and do different things. So the process doesn't have to understand this resell thing. It just has to understand how to accept the reality that the destination has changed, right? That things can change over time. I do want to get into one other thing about this era of time and distributed systems. Is on Twitter, I talked about the number one benefit in my mind for event source systems. And that is about having a single, in distributed systems, if you've got more than one thing, you're going to do a giant failover. Something's gone wrong. Somebody's run a truck into your data center. Your data center was in France and it burnt to the ground, right? Yeah. You've got to fail things over. And how you get everything to come up together in one position is one of the hardest things to try and figure out to do. If your data centers are less than 3 milliseconds apart, you can do desynchronization on every service and poof, it's magic. But as soon as you've got something that's really distributed, really worldwide, that doesn't work. And especially if you want to do commodity hardware in the cloud and not spend $1 million on your own to, data centers you've built.
Yep.
And just take an example where you've got an approval service and a processing service, and the processing service takes in a request, gets an approval, ties up the resources, and then starts processing, and you fail over.
Yep.
And your approval service is better than your processing service. It remembers the approval, and your processing service doesn't remember the request. But you're within your SLA, and the upstream system resubmits the request. And now your approval service is going to deny it because it's already decremented the resource required to run the approval, right? Something's already open. There's already a pending thing for, $10,000 on the account, right?
Yeah.
With event source, with event store and event sourcing as your core, you can use a vector clock on your all stream because you have an all stream position. And when you restore over and you come back up, you can tell, hey, everybody, we're all at point whatever. Truncate to that point or read and catch up to that point. So if your database failed over with that in-flight thing using the pattern we talked about before, right? It's like if I wrote down about to request approval, about to do this, I'll have all the information I need to fully restore to the same point across all of my systems. And I think that, in terms of pain, is the number one benefit I've seen building real systems. The number two benefit is obviously that we don't lose any data.
Yeah.
They're really neck and neck.
Yep, I agree on that. Okay, so the next one's a lengthy question, but I'm just going to say one word and that'll probably give you enough to talk about it, which is uniqueness.
Uniqueness?
Uniqueness and how you handle it.
All right. So,
just to give a bit of clarity on this beforehand, this is one of the most common questions that's asked in an event when people start picking up event sourcing, is that because you do have an eventually consistent read model, how do you validate simple things like somebody hasn't tried to register with the same email address?
All right. Well, the simplest possible way to do it is I'd use EventStore and I do user-email address as my stream name.
Mm-hmm.
Right. And so I use the stream consistency locks in the event store, or maybe I might hash, you can do deterministic GUIDs. If I do a deterministic GUID off of the email address, or I do a double hash of the email address, I can ensure I can't recreate that stream twice.
Do you want to explain what a deterministic GUID is?
So a GUID is designed to be, random and unique and based on your local clock and all these things. A deterministic GUID uses much of that, but then gives you a guaranteed number that's unique for whatever input you give it. So if I give you the string, I'll always get the same GUID out, which means it is not as random as a true GUID, but it gives you the benefit of always generating the same number. And you can use that. So the simplest thing is if I can't create a stream, because EventStore will tell me, no, you already built that stream. That's the simplest hands-down way to do it. The next step is to create a read model where you're going to actually have all of those things you want to check available to you, at startup time. And there is a gap there where, something might sneak through. And that's one of the reasons why I use circuit keys. So that's why the email address has the ID isn't a good idea. Mm-hmm. And two, you've got to understand how likely is it that this is going to happen where two actually different people try and register the same email once.
Within milliseconds of each other.
Right. Now, having the same person register the same email twice because their websites got cut off and they resubmit, that's very possible. You deal with that very differently because then you're just merging the accounts. And as long as you have a unique ID, it's fine. Now, the other aspect of this question, so that's like the pure uniqueness. But the other thing that people often bring into this question is something like Ticketmaster.
This is what I was going to say, is uniqueness in an email address. You could get away with two people having the same email address. It's not going to break your system. But overselling tickets.
Right. So now, if your business model says yes, oversell, that's also something I'm not going to talk about. But what you do here is you use that same reservation pattern.
Mm-hmm.
When someone comes in, you reserve the seats and then you commit on them. And that actually, you do this right ahead pattern where I'm going to go to a pool, I'm going to reserve the seats. The reservation is going to be locked. So I have one stream tracking reservations and locks and unlocks in atomic committed fashion. And then I can do all the processing I want. And if the transaction doesn't go through, I return them to the pool.
Yeah,
and you see this pattern all the time.
Yeah, and you see it reflected in the UI as well. Is that when you buy a ticket, you purchase a ticket, and it says you've got 15 minutes to put through pay for it, and if you don't, then you lose the ticket. And
100%.
Yeah, so you effectively there you are reserving the ticket, and then you're purchasing it.
Yeah.
So you put in a lock on it. Cool. Yeah, I mean, I often find that like the requirement for uniqueness is probably not always as strong as one might think. Sometimes it's often a business problem because, I mean, before computer systems came around, you know, the ability to have uniqueness was pretty much non-existent. So, you know.
Right, and if you build your system so that the email address has to be unique, and can't stand that. I mean, you probably want to build it in a more robust fashion, because there are cases where things might happen that you might not expect that you need to allow for in the real world.
Yep, absolutely. But that question does come up almost daily. Okay.
I think it's because people are coming from a transactional and relational, system where they can lock the world and do that. And so they're saying, well, how do I lock the world and make sure things happen? Right. Yeah. If I really wanted to, now that, and I think they don't understand the power of sync over async as well, because I can actually block the user from moving forward, and I can scan all of the current records, and I can have a local cache of all of the in-flight email addresses. So if I have a read model with all the ones that are persistent, and I have a Redis cache of all the ones that are in flight, right? And I say the first thing you do is you try to see if what your email address requesting is in flight. If it's not, add it and then move on.
Yep.
You are suddenly just dropping. You're closing that whole window, and it's just a matter of, you read the BigQuery. I do it, and the whole time the user's blocked because my system is running asynchronously, but I've just paused them while I go do the work and come back to them.
Yeah, I do feel it's a lie that we've told ourselves, and the people buying our products at the world is consistent, and you can stop everything.
I mean, because it's a brilliant thing that they came up with to stop the world and be like the Flash and run around the room and knock the bullets out of the air, but it just doesn't go beyond the one room. And now we need to build things that are everywhere.
Yeah, 100%. All right, let's try another one. And this one's from me, because it's a question that comes up quite a lot. And I always think it's interesting because when you come across event sourcing, you immediately come across two other terms, which is domain-driven design and CRQS. And there is an opinion that you can't do event sourcing without first looking at domain-driven design.
Yep.
So the question is, do you think DDD is a prerequisite for event sourcing?
Hold on, I'm going to mute my phone here, which I foolishly failed to do before we got started. So no, I don't think neither CQRS nor domain-driven design are required for event sourcing. I was building event-driven and in some cases event source systems in the 90s where neither one of those terms were invented yet, right? If you look at the eventing model inside of a car, if you look at the way it works inside a phone system, it's not required in any way. What CQRS is a way to say, hey, let's stop violating the single responsibility pattern when it comes to our data stores. And I find it an enabling pattern to make event sourcing on applications easier, right? But it's not required to do it. And as soon as you start thinking about, well, if I'm writing to the store and I'm doing a live push back to my app with an ephemeral read model, like where's the second database? I'm really writing and reading events from the same place. And as I grow, now I'm going to do multiple targeted read models. Now I'm going to do my graph query separate from my write. Now I'm going to have my reporting database. So as I grow and I want to do more things, yes, I'm going to use CRQS, and it's really powerful. But if it's a pure streaming system, like I was working on a system where temperature sensors and smog sensors all over the world, like in China, and it's all about IoT data streaming in and storing up histories of what's going on a sliding window. That doesn't require domain-driven design. What you do want is you want your events not to be tied to your microservices and with the processing today, right? You want them tied to your business model. And I find that domain-driven design is one of the best tools I've ever found for eliciting and understanding your business model and the terms to use for the events, right? So you want to do the isolation patterns. You want to have, per instance streams. DDD is a wonderful tool for achieving that, but is by no means required. Same thing with CRQS. It's a wonderful tool for being able to do multimodal systems with optimized query and write, but it's not required depending on your use case.
So that kind of leads me to say, like, one of the arguments you see against event sourcing quite a lot is that, like, once the system gets into production, it's a lot harder to fix, which is where the idea of a prerequisite for domain-driven design and better understanding your system before building it comes from. So you get it right first time, and therefore you don't have to change it once it's production.
So, I mean, that to me, that's hand in hand with another one, which is once it's append only. So once you put it in production, it's going to grow enormously, and then your whole system is going to fall over and die, right? And what I find in practice is that event-driven systems are easier to fix, and their footprint on the database is smaller than any equivalent system I've written in relation. Because I spent years working in insurance and working in finance, doing a lot of high-level work with relational databases. So I know them, I've used them, they do amazing things. I've taken them to enormous scales, right? So this isn't like, oh, I never used that and I'm just going to trash talk them. Looking at them, if you think about how do you fix, people say, oh, well, I can just add a new column, and as long as my queries are, dash star or not, I don't use dash star, nothing changes. I give it a default value, I add it, it's fine. What happens to your history table? What happens to your audit table? What happens to your reporting database? What happens to all your historical data when you make this simple change, right? If you haven't planned for growth and you haven't planned for this, you get tangled up in any data system you use. What I find is that if you implement good data management, so you have an archiving strategy, you close the books on a regular basis, you scavenge and remove the events you don't need. And as you write events, you're not writing a copy of my entire state every time. You're not doing change data capture where you throw away all your information. You're not doing snapshots in a stack and calling that event sourcing. Your event sourcing data model should be like a third normal form model, right? No duplicate fields. Everything has an owner, right? Everything is tied to where it's going. When you do these efficient models, you wind up with a lot less data because people see the ER diagram, they go, oh, that's how big it is. But then they've got, their reporting diagram and their history and this. With event sourcing, you don't have those 5 other models surrounding it unless you need them. And they're ephemeral or recoverable, so derived data that you can rebuild. So your core data is only that core diagram. And that keeps you much smaller and much leaner and faster. You keep it clean, it doesn't grow. And When you need to change something, there's a couple of different things you can do. One, you can apply a corrective event. So, hey, we made a mistake. I'm going to put another event on and make another change.
So before you go into this, I want to ask a question which is about this.
Okay.
So one of the questions which was asked, well, first of all, I want to make 2 points about, disk usages. But generally, events are, if designed correctly, incredibly small. I mean, it's even possible to have an event that has no data other than the
yeah, it's just the name.
Yeah.
Activated.
Yeah.
Right.
If there's nothing else required, then they can be tiny. But the question was basically, how do you go about fixing bad data due to bad? How do you go about fixing bad projected data due to bad event data due to bugs or whatever? So far, we've had to produce one-off corrective events for these instances after we fix a bug producing a bad event data. Is there a better way? So yeah, basically talk about fixing a bug
So I'm going to do a callback to something I talked about earlier with the write ahead pattern, and I said you have a process that watches for mistakes in that processing, and I tend to like to use this pattern. I call it canaries versus tanks. When I first started building systems, I wanted to build tanks, right? They never go down. They cover every possible use case. They're always going to work. Instead, I want to build now canaries like a canary in a coal mine. If there's a whiff of gas, something goes wrong, it falls over, right? And you have something that watches it and stands it back up if something went wrong, right? And that concept, means that when I write that, I've got something which can do ongoing audit my system. When I do recovery and failover, which, as you know, is one of my most important aspects, I start it up and I run the recovery process, right? So now my failover is taken care of. My ongoing audit and reconciliations take care of it. My failover is taken care of, and my code is simpler because I'm not trying to do anything. So I have watchers and recovery. With all of my read models, I want to have the same thing. I want to build in from day one the ability to rebuild and reset any read model I have.
Yeah.
And very often, what I'll do is I'll have it rebuild a read model and atomically swap it for the current one, right? So that's how mechanically we're going to rebuild that read model, right? Is if we can apply a corrective event, we're great. We just applied update current. If this change is like, oh, we screwed something up, it's going to rewrite half my read model and it's not going to be correct until it's done, then I'm going to do a rebuild and swap.
Yeah.
But there's other times where you just got to break glass and go, hey, I need to restate the data, right? And the same way you restate data in accounting. And that's where I'm going to rebuild this whole stream from the get-go, because there's times where it's like, oh, this model is totally wrong. We can't fix it. We're going to take all the same data. We're going to project it into a new stream, or even, worst case, you're projecting a whole new database, right? Rebuild it all, rebuild your models. And with a properly built, distributed system, you can atomically swap that in place. And I've even been able to do things like that on live running systems. It's not easy. If you don't need to do it, don't do it. Take a maintenance window on Sunday night if you've got it, 100%. But you can rebuild and do that. And oftentimes, this is one of the benefits of something like snapshotting that people often don't talk about as well, is if I do a corrective event, I might do a snapshot right after it. So my read models aren't paging back down into the old data to be able to have to write all the wrong stuff and then write the correct thing and go back.
Yeah.
Also, when I change event schemas, add a new event type, I'll do a snapshot as sort of a point in time. And then the last place for those snapshots is when you're closing the books. And you're like, hey, I'm going to archive everything from here back. The opening entry on the new stream is a snapshot of the previous state. So if I have an archive or, audit need to go back and read all the old data, I have it. But my new stream starts with a snapshot, which is my opening entry, and then moves forward.
Sounds good. We are very close to the end. We've had one question whilst this has been ongoing, which is from Juan, which is about Kubernetes. I don't know a massive amount about Kubernetes. I don't know about you, Chris. But the question was, the official Kubernetes Helm chart was discontinued a year ago. A blog post was published back then saying that efforts were turned to creating a Kubernetes operator. Has there been any progress since? I'm aware of the concerns expressed in that post, but Kubernetes is a requirement for us, and right now Kubernetes users are in limbo.
So what we have found in general, so I don't know the actual status of that, to give you a concrete answer at the moment. But what we found is that running a production database on Kubernetes is a non-trivial thing to do, right, for any significant system. And what we found is we were giving basic setup guidance, and people were using that in production. And so what we found is that anyone who wants, I believe, people that want to, ask us questions about how to set up the database correctly and understand what they need to worry about in Kubernetes, we can offer support to. But given the nature of the various workloads, there isn't a cookie cutter solution that's really going to work for everyone across the board on Kubernetes. And I think that's where we're at. I believe we're revisiting it. I know we also have a cloud hosting offering.
I'll pitch that in a second.
Yeah. But we're kind of stuck on, because how you set up Kubernetes to make sure that you've got the right resources, the right disk, the IO, connectivity, it's just really non-trivial and very application specific. And how you want to do it for a very large database and small doesn't work. How you deal with, part of the nature of Kubernetes is being able to have nodes come up and down freely and scale out. And the database cluster really wants to be 3 nodes, and the 3 same nodes, and have known resources to be able to provide a consistent performance experience, just like any other database.
Yeah, I mean, this isn't something that's specific to EventStore itself.
Not even close.
No, but to that end, obviously, if anybody hasn't seen it, we have a cloud option available now. So if you are running in, be it GCP, AWS, or Azure, then we actually have a service that will allow you to spin up and create instance of EventStoreDB, which we will manage for you. So you should be able to use those in conjunction with Kubernetes as another option.
And I know we do have customers who are using Kubernetes. So if you reach out on the forum and in the community, I'm sure you'll find lots of great resources on that.
By all means, we have a website which is discuss.eventstore.com, where you can jump on and you can ask any questions there as well. We'll answer them to the best of our ability. We're out of time, pretty much. So thank you very much for your answers, Chris. They were pretty insightful. And thank you for people who have attended. This recording will be available online soon as well, should anybody want to watch it back. Because of my mumbling, then by all means, please do. Otherwise, thank you very much.
All right. Thank you. Have a great time. Bye, everybody.